Hi students, you are welcome back. In today's episode, we want to take a cursory look at an aspect of physics that usually give students problem, and that is a moment of a force. Now, moment of a force, of course, the theoretical aspect has been taught, and the students, they have comprehended the aspect, the theoretical, remaining the calculatory aspect. In today's class, we want to find a solution to most of areas where students usually get themselves locked up. And in doing this, there are some things we need to put into consideration. More often than not, in moment, they always refer to a body being balanced on a meter rule. Here is a meter rule. And by the word, meter rule simply means 100 centimeter long. When you hear the word meter rule, that is a 100 centimeter long. That is, a meter is equal to 100 centimeter is equal to a meter. That is a 100 centimeter rule. And again, when you are dealing with moment, you have to bear something in mind. Is it a uniform body or non-uniform body? If the body is uniform, of course, the center of gravity is going to be at the midpoint. That is at the center. But if the body is not uniform, the center of gravity will never be at the center. So the moment the question is given to you, one, you have to consider what is the length of that plank. If it is a meter, that is 100 centimeter. At times you can have other lengths. It could be 5, it could be 6, it could be anything. But now here the one I'm having is a meter. That is a 100 centimeter long. And again, it is a uniform. You have to continue to look for that word, uniform. If the question is silent about the cross-sectional of the body in question, we always assume it to be a uniform. If it is non-uniform, it will be spelled out. It's going to be stated that a non-uniform body. But the moment the question is silent or a uniform is emphasized, then it means the mass of that body will act at the midpoint. Now, here we are having 100 centimeter. Of course, you expect the center of gravity, which is the point where the weight of the body seems to what? To act. So now it's going to be at the midpoint. And of course, we talk of the fulcrum, that is the pivot. Now, when you place your body on the pivot, of course, it's going to swing. If it is at the midpoint, it's going to balance horizontally. And if it is far away or is away from the center, it means it's not going to balance. It's going to what? It's not going to remain horizontally. Now, we are told that this is a meter rule. And if you are asked to calculate the mass of that body, as I said, the mass will be at the center of gravity. That is at the midpoint. Now, if you are told that this is a meter rule, and it is 100 centimeter long. If it is pivoted and the something balances, mark you, it is a uniform. Then we expect that from here to here to be 50 centimeter. And from here to here too will be what? 50 centimeter. That is if no weight is hung. But the moment a weight is hung on this, definitely is going to change. Let's say I hang a weight of X Newton. You will not expect this to still be at the center. It can never be at the center because we have hung a weight at a distance. Now, we have to find the balance point. That is, you continue to adjust your pivot, your knife edge, until the something balances. That is going to That is where something is going to balance horizontally. Now, if they ask you to now find the mass of a body, you should know that the mass will be at the center of the entire length. That is going to be at the center. So now, that is, then another thing is, when you are studying moment, the moment I place this mass here, of course, this one is going to tilt this direction. Then to balance it, this one, it has to go this way. Then we now talk of the principle of moment. And basically, we have two. What does it say? That is, look at this. This is clockwise. That is, this is how the arm of the clock goes. This is clockwise. Clockwise, the moment is telling us that is the principle of moment. It's stating that if the body is in equilibrium, that is a conditional statement. If that body is to be in equilibrium, it means the sum of clockwise moment. Here we have clockwise moment. The sum of a clockwise moment must be equal to the sum of an anti-clockwise moment. That is, if that body is what? Is in equilibrium. That is the first condition. That is, for a body to be in equilibrium, the sum of a clockwise moment must be equal to the sum of anti-clockwise moment. Now, let's say I now have another weight, another body that is hung at certain distance from the pivot. Let's say I'm having here, we have P Newton. That's another weight. Now, for this body to be in equilibrium, I have to know what is the perpendicular distance. Where am I taking the moment from? Let's say this point is a point Q. Point Q. The distance from here to this point Q, let us call it A. And the distance from this body X to the pivot, call it B. Now, we want to go to the moment now. How to calculate that moment. What is the moment telling us? Because I'm having just only a support here, I'm going to deal with this clockwise and anti-clockwise. I'm going to deal with clockwise and anti-clockwise. Now, if this body is in equilibrium, I want to take the moment. Where am I going to take my moment, class? I'm taking my moment about Q. Why do we say taking moment about Q? Because that is the point where it's going to turn. That is the point. You have to notice where is that body turning. So where is it going to turn? So I will now say taking moment about point what? Point Q. Class, taking moment about point Q. And when you are taking moment about a point, the summation of moment about Q must be equal to 0. Why? Because it has magnitude, but the distance is equal to 0. Where am I taking the moment from? I'm taking it here. Where is the perpendicular distance? It doesn't have perpendicular distance, so it is equal to 0 there. Then now, let's go to our clockwise moment. What is our clockwise? Clockwise moment, class. Look at it. Where am I taking the moment from? I'm taking it from this point Q. So it means all distances will be referred to this Q. So it's not going to be, what's our distance now? It's going to be A times this. So now we now have A times P. That is my clockwise moment. What about my anti-clockwise moment? So the anti-clockwise moment, what is the anti-clockwise moment there? We now have, where am I taking the moment from, class? I'm taking it at point Q. So what is the distance? The distance is going to be B. So I multiply. It's now going to be what? That is X times what? Times B. So going by the principle of moment, that is the sum of clockwise must be equal to anti-clockwise. So it now means AP must be equal to XB. That is if the body is to be in equilibrium. I hope I'm talking. Is that understood? Now, we have a question, and it goes thus. A meter rule. Hey, look at the word. A meter rule. A meter rule. That is 100 centimeter. Is that understood? 100 centimeter. So I place, that is my 100 centimeter. 100 centimeter. Remember, the other time I told you, if the question is silence about the cross section of it, you will assume it is uniform. Because if it is non-uniform, it will be clearly stated. Now, they say a meter rule is pivoted at the midpoint. Where is the midpoint of 100? That is at the 50 centimeter mark. So I write, this is my midpoint. It's pivoted. You can see it is pivoted at the midpoint. Always indicate this is 50 centimeter. Am I? So we have 50 centimeter. It is pivoted there. Now, with a vertical force of 25 Newton, vertical force of 25 Newton hanging from a distance of 45 centimeter. From where? From B. Where is our B, class? This is where they call our B. That is our pivot. Are you getting now? They say from where? From B. It means I'm going to stand here, not here. Because they say from B. So it means I will measure off my 45. So let's say my 45 is somewhere here. So I have to indicate. This is going to be my 45. From here to here, that is 45. Class, if this place is 45, what will here be? This, of course, is going to be 5 centimeter. Very good. And what is the weight? It is 25 Newton. We have 25 Newton. We are there. We are here. Now the question now says, at what distance must a 30 Newton force be hung in order to balance the ruler horizontally? You should know that you cannot place it here, because already you have placed a weight here, and it means our rule is already this way. So you have to balance it. How do you balance it? If you place here, it will further go down. To balance it, it means you have to come to the other side. So I don't know where to place it. Just place it anywhere. So what is the weight? 30 Newton. Very beautiful. So it's bigger than this. So this is 30 Newton. I don't know where to place it. Call from where you are placing it to this, where you are having your support. Call it X. Call it X. Class, if you do this, you are in a way to getting the correct result. Now, because at times in some questions, they will ask you to what? To draw the forces. Now, you can now see that this is my perpendicular distance. This is my perpendicular distance, because moment of a force is the product of force and the perpendicular distance from the line of action of the force to where the body is now placed. So we have this. What is, you go this way. Class, what is this one? Of course, this is our clockwise. This is our clockwise. I'm not going to say the sum because I have only one. I didn't have so many weight. I will have added the clockwise. Now this one is going to be our anti-clockwise. So this one is going to be our anti-clockwise. Anti-clockwise moment. Now from the principle of moment, if you want to now tackle this, you have to state where do you want to take your moment from. I will now say, taking moment about which point? Point what? Point B. Taking moment about point B, because this is where the body will be turning. That's where it will be turning. I will now say, therefore, summation of moment about point B must be equal to 0. Summation of moment about that B must be equal to 0. So let us now say, Now, we have taken moment. So let's go to what's our clockwise now. That is the force and the distance. Our clockwise moment is going to be what? Force times distance. Force times distance. That is 30x. Our anti-clockwise moment is going to be, look at it, it's coming to this point point B. So that is 25 times 45. That is 25 times 45. So from the principle of moment, summation of that is clockwise moment must be equal to anti-clockwise moment. Now what is that? What is our clockwise? 30x is equal to 25 times 45. Are we there? So you divide through by what? Because we are looking for x. You divide through by 30. So divide this by 30. This one too by what? By 30. This cancel this. Oh yeah, let's go. 6, 5 here, 9. 9 times 25, that is 225. All over 6, which is going to be 37.5 centimeter. So it means the distance at which this 30 Newton must be placed in order to balance this meter rule must be at 37.5 centimeter. From where? From B. From B. That is where it must be placed. The moment you place it at that 37.5, honestly speaking, the body will balance horizontally. Class, if you find it interesting, do subscribe to the channel and like the video. Thank you.